Hello, my name is Martin Anderson, and we're going to take a closer look at my C++ calculator. I am first off going to show you the program itself, just going through it option by option here. We can start off with X for clear. Clear, clear. Nothing's happening, I have not given it anything to clear. So let's move on to add. First value, 20. Second value, 5. 25. Clear. As see, clear works with both uppercase and lowercase. Then we're going to move on to subtraction. Let's give it 50. Well, it's 5 again. 25. Let's multiply that with 2. Let's divide it by 2. Now, modulus. Let's see here. Let's give it modulus 10.5. 4. But the thing I want to show you is it worked also with non-integers. But let's try that again. Integer 1. Let's give some random values here. It's going to give us. I would love to say I could do this in my head, but I can't. That is not something I'm capable of, sadly. Let's see here. Then we're going to delete remainder. I was, to be honest, not sure what was meant by this. Some paper was saying just remove anything behind this decimal point. I prefer rounding it. So mine is over 0.5. It's going to excuse me. It's going to be 1. And if it's below 0.5, it is going to be 0. Now, because I'm just going to standard way, so if it is 0.5 precisely, it's going up as well. And you may see that here. 1. We can give another example here, showing it all going down. Say 50.2. Delete remainder. Just for clarification, plus 0.5. Now I mentioned it. Delete remainder. 51. Now we are at cosine. Cosine, sine, and tangent. I am, instead of just using the radians the program gives me, I'm converting them to Celsius. I think that's more useful for a standard use calculator. So we're going to write C, give me the cosine of 51. I can do that with sine and with the tangent. Now you just have to have my word that this is correct. Just used 50. Give us better. Oh, sorry. So many decimal points here. Oh boy. I'm not really rounding enough on any way. I could have done that, but say 50. I think 25. And then the square root. Of a road. 5. Exponentiation. What a long word. Oh boy. 2. 25 again. Well, we can get the big numbers. Infinity. It has its limitations, of course. Just being long doubles. Now we have change value. This is something I added myself. It was not a requirement, but I like it on the normal calculator. When you just press in numbers, that's going to be the value. So with my limitations of having the switch case, I'm just going to have a V, and then I can write anything I want. You have probably seen me do it before, but instead of having to write like, do we start over and I want something in, I cannot just write 2. Nothing will happen. And I still want to have 0 to get my number. And that leaves us to the last option. Let's press Q for quit program. Press any key to continue, and we are back here in my code. I hope you can read it. We have here, I include 3 libraries. I have my IO stream for cout, cin, all that stuff. We have the math. I use the math library here for a couple of the functions. Actually, pretty much all of the those who aren't the standard operators. And we have including the stdlib.h. This one is for my way of exiting the program. I could have done this other ways. Yeah. Because I am converting my radians to Celsius, I have chosen to define pi here. Just, well, it's also part of why I'm getting these insanely numbers. Because I am using a pretty precise pi here. Of what our annotations are in the program. Now, my main function here. Here we have my two types of variables I'm using. I'm having a jar type, and I have the long double. My jar type is for what type we're going to calculate right now. Well, I was not this fanciest name, but I'm using a jar because we're only using one sign here. I thought jar fitting. Very fitting indeed, but we have the long double. We have that for our current number. Current number is what is shown as our current value in our calculator. Then we have input 1 and input 2, which are for the calculations. We always have a maximum of 2 numbers we're calculating with at any given time here. We go our loop. I'm making a for loop with nothing, which will result in a for loop going forever and ever. Just drawing it. And we're here asking, give us type. What do you want to enter? And here I have something I wrote myself. I am having an if statement. I'm saying if my type has a decimal value from 65 to 90, I'm pretty sure this is a capital letter. And I know this because I just took a look at a Haskell table. And on this table I could see that, well, the lowercase and uppercase letters are all 32 apart, so I'm just giving a plus 32, and they now turn lowercase. So when we go to my switch case, I can just say, well, lowercase x, instead of having to write both. I'm just that lazy. But yeah, so this one clears the menu, and that is pretty simple in this program. It is just giving it the current number a value of 0. Now move for something cooler here. Case addition. If not current number, so if our current number is 0, basically, we're going to ask for the first value, because I'm pretty sure when you're at 0, it's like starting over on a calculator. But if there already is something, use it. Otherwise, the user's not using my calculator the way I intend them to. Oh, stupid users. We are now here and we have our first input. No matter what, here we're going to get an input 1. Then we're going to say input 1 plus, and then we need input 2. User needs to give us that, and then calculation, surprisingly easy. Input 1 plus input 2. Break. Leave the case. Skip out of the whole switch and start over at the loop. And well, subtraction, it is the same principle as addition. And it really is. I have only changed this sign and this sign, and it works perfect. Same goes for multiplication and division. Now let's move on to modulus, which is a bit different. Instead of using the modulus sign in C++, I'm using fmod. This leaves me with the opportunity to use something else than integers. I can now use floats as well, which I also showed early on. And my delete remainder. Like I said, I was unsure about this part. I was not really knowing what I had to do with it. So I just give it math round to remove the decimals. I have no idea what I was going to do. I could have, instead of doing this, I could have converted it to an integer back to float, but I just thought that was unnecessary to do. Okay, C. cosine. For this cosine here, I'm just doing the math function found in the math library, cos. Give it the input. This would just give us the answer in radians, so I'm just saying multiplied with pi divided by 180. Break. And the same goes for sine and tangent. Then square root, just going to give the squared sqrt square root function in the math class. And well, I wanted to use as a q for this one, but well, they were all taken. Sine quit. We have our case. You know what this is called? To the power of pow. We're using a math class once again, and we just say input 1, input 2. This works with floats as well. Case V, changing my value. This one is very simple. I just ask for a value, and I'm going to change that value to the current. Change the current number to that value. And we have case Q, quit. There's actually no real way to leave this loop. I'm just closing down the program. And we have default. If this is just if anything else than alpha above, it's going to do this. Invalid comment, read the options. If you just run it like I did before, you're not going to actually ever see this line unless you scroll. And that concludes the program. Thank you for watching.